Okay, so we are going to look at the function y equals the square root of x minus 2. Y equals the square root of x minus 2. Yeah, I'm using my pencil for this. I'm not doing a color yet. And so if I wanted to graph this, since it's a square root graph, the points that I would use for a square root graph, oh, it's an orange, that's not helpful. Okay, I'm just going to do it from memory. 0, 0, 1 is a good number to square root, so 1, 1. Not 2, not 3, 4, 4, 2. 5, 6, 7, 8, 9, 9, 3. Okay. So these are the points we usually start with for a square root graph. Does anyone remember why I'm not using negative values? Because they're undefined, you can't square root a negative. Because the square root of 9 is 3. I just made it a little bit bigger, yeah. What would be my next point? 16.4. So it was a typo. 25.5. Yeah, there we go. Okay. So now, what's the transformation here? Right to. Okay, so how do I shift all these points right to? Okay, so I'm going to have 2, 0, 3, 1, 6, 2, 11, 3. Okay. So I'm going to go ahead and make this. So I'm going to make all the points are positive, so I'm only going to draw the first quadrant. And I'm just going to make sure that both my quadrants go to at least, or both my lines go to at least 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oops. 3, 6, 9, 12. So I've got 2, 0, 3, 1, 6, 2, 11, 3. There's my square root graph. Are we good so far? I mean, what's the, can anyone see what the domain of this function is? Yeah, what's the domain? Okay, so the furthest left that the graph goes is 2. And then the furthest to the right that it goes is a positive infinity. And then what do we put around the 2 and the infinity? Okay, so bracket for the 2, parenthesis for the infinity. Okay. What's the range of the graph? How far down does it go? 0. Okay, it goes down to 0. It goes up to infinity. Okay. bracket, parenthesis again. Okay. Is there an x-intercept on the graph? Yes. 2. Okay. Okay. Is there a y-intercept on the graph? No. Okay, so I'm going to write none. Okay. So I'm just going to write us a little reminder for this, and you'll understand why in a second. So the domain is x values. This is an x value. This is an x value. The range is y values. This is a y value. This is a y value. The x-intercept is a point. So it's an x-coordinate and a y-coordinate. The y-intercept would be an x-coordinate and a y-coordinate as well, but we didn't have to find it because there wasn't one. Okay. Are we comfortable with all of that so far? Yes. Okay. Now, let's go through and let's use what we learned over the last couple days to find the inverse. So when you find the inverse from a graph or a table, it's a little bit easier than doing it algebraically because we literally just use the idea of trade the x and y, right? And then we're like done because that's all you can do if you don't have an equation. So let's go ahead and take these points that we had here and let's just find the inverse. So what's the inverse of 2, 0? 0, 2. What's the inverse of 3, 1? Oh, yeah, I switched colors to find the inverse.
Wait, what other thing?
Oh, I was using pencil for the whole function to begin with.
Oh, okay.
And now I'm switching to the other color for the inverse. Yeah. Okay. So the original function was 3, 1. The inverse is going to be 1, 3. The original function was 6, 2. The inverse is 2, 6. Okay. The original function was 11, 3. The inverse is 3, 11. Okay, let's go ahead and graph this. Okay. So we can see the graphs. Did I talk about in the video that the inverses are reflected over this line?
It's reflected y equals x.
Over the line y equals x. Okay, let's write that down. This is the line y equals x, and it's reflected over that line y equals x. Okay. Which makes sense because you're trading the y and the x, so it should be reflected over that line. Okay. Let's come down here. Okay, so if I look at my other graph, and I look from left to right, how far left does the graph go? And how far right does the graph go? Infinity. Okay. So if we compare the answer that was the range before is now the domain. Okay, now let's look at the range. Okay, so if we look from down to up.
We're going from 0 to infinity.
Wait, 2 to infinity. So the answer that was the domain before, is now the range. Does everyone see that? So the numbers that used to describe the y's now describe the x's, and the numbers that used to describe the x's Now describe the y's, because the y's and the x's traded. Does that make sense? Okay. Now, now think about this. Does it also make sense that these two numbers did not trade positions?
Does it make sense if they did it?
Yeah. Think about how it makes sense that they should not trade positions because they're both x values. The x values shouldn't trade positions because they're both x values. These are both y values. They shouldn't trade positions. Yeah. X trades with y. But if these are both y values, they shouldn't trade positions in the answer. Yeah. Okay, so let's look at this. The thing that used to be an x-intercept is now what? It's now a y-intercept, and that's because the x and the y traded positions. So now it's a 0, 2, because the x and the y traded positions. And now if we look for the x-intercept, we're going to find that there isn't one. Okay? Everyone see that? Now pay careful attention to this, because these are the questions on the test that my students often miss. And it's because they will, here's the common mistakes. We're very chatty today. And you're chatty on the problems that I'm telling you students often miss. Students will take the domain and they will tell me the range on the new function is infinity, 2. Should you switch the order? No, because they're both x values. You don't have to switch the order of two x values. You don't have to switch the value of two or the order of two x values. Okay? So all you're doing is trading x and y's. So when you've switched, when you took something that used to describe a domain and you make it describe a range, that is you trading an x and a y. Does that make sense? So we don't need to switch their position because we already traded the x and y when we said it used to describe a domain and now it describes a range. Same thing vice versa. If it used to describe a range and it now describes a domain, we did trade the x and y's. We don't need to trade the position of the numbers. Okay. Now these ones we did need to trade the position of the numbers because one was an x spot, one was a y spot. So those actually do have to trade for it to make sense. Okay. All right. Now let's look at this because we had a square root function, and when we did the inverse, what did it become? A parabola, but did it become a whole parabola? No, it became half of a parabola. Okay, so let's look at why that happens. So if we look at this, we're going to start with saying we have this. This is our function. When we find the inverse of this, what is the inverse? What do we have to do?
Square root it. Square it.
No, what do you do? Remember yesterday was the very first thing we did. Trade the x and y. We say x equals the square root of y minus 2, and we said if mathematicians weren't so particular, we would be done.
But we're not, because now we have to square it.
But mathematicians are particular, okay? So this is where we say, okay, let's do some work. I'm going to do my work down here. I don't know why I did that.
That was so unique.
So unique. Miss Rice, you're so cool. Okay.
Hey, Rice.
So
Equals y.
x equals the square root of y minus 2. Okay, and so what do we have to do first? Yeah, we have to square both sides. So x squared equals y minus 2.
Add your 2, and then you're done.
We get x squared plus 2 equals y. And if you can tell, does this look like a parabola that's been shifted up 2? Yeah, okay. But it's only half of a parabola, and it's only the half of the parabola on the right side. So what we would say is this is a parabola, yes, but we would say this is a parabola with the domain of 0 to infinity. And we would have to be very careful to specify this. Is this going to show up on the EOC? No. Am I going to put this on one of my tests? No. Is it good for you to be familiar with this because in more advanced math classes this is important? Yes. Okay. So then at least you saw it and it's not a shock, okay?
Like, I have a question. If I took one more math next year, would I like be done with math in high school?
If you get 4 credits, yes. Well, you have to have 4 math credits in high school. I would talk to your counselor. Yeah. I would talk to your counselor. All right. So one thing we're going to look at today is we're going to be careful. Listen carefully. We're going to be careful when we look at the graphs to see, should we have the whole picture or should we only have half of it, okay? And it's going to show up in today's assignment towards the end. And when it does show up, they're going to be very specific to ask, do you want the whole thing or do you only want half of it, and how can you tell? Okay? And when we get there, I can help you guys with those because I do know that those are kind of funky. But that's one thing to think about, and it's something you have to think about specifically with square root graphs. Those are the ones that are weird. Okay? And you can tell that it happens with square root graphs because whenever you guys solve a square root equation yourself, you guys remember that if you took the square root of something, you really should put a plus or minus in front of it. Do you remember that from like math 2? Because if somebody said, hey, take the square root of 4, what's the answer? And you said 2, you'd only be half right because the other square root of 4 is negative 2. Or what's the square root of 9? It's 3, but it's also negative 3. Yeah. And so that's what kind of tells you that there's technically 2 answers, but a lot of us do default to the positive. That's kind of what this is getting at, is that when we look at a square root function, we're only really looking at half of the picture here, because the other half of the picture is that we could have the negative version, which would actually be underneath the line down here. All right, so it's something that we naturally do all the time. We just don't really think about it because we typically only consider the positive. Okay, so this is what we've got. I'm going to go ahead and hand out the assignment for today, and we'll go ahead and start it together. So the big thing you have to remember today is trade the X and Y. That's the big thing you have to remember. Ooh, before we do more work on the assignment, I forgot that I wanted to practice some notation with you guys. So at the bottom of the class notes, let's write notation. Notation. All right, if I say f of 3 equals 1, then you could tell me that f inverse of 1 equals 3. Does that make sense? So if I plug 3 into the original function and my output is 1, then that means in the inverse I could plug in 1 and my output would be 3. No, because this is just switching x and y. Okay, so if I took my original function and I said f of 6 equals 2, then what could you tell me? F inverse of, not 6. F inverse of 2 equals 6, okay? If I told you f inverse of 9 is 7, what could you tell me? F of 7 is 9. Okay? If I told you that f of x had a domain of 3 to infinity, what could you tell me? The f inverse of x, not a domain, would have a range. 3 to infinity. You'd keep it exactly the same. Because remember, domain is x, x, and range is y, y. Good. Very good. Okay. If I told you, let's try another one. If I told you that f of x had an x-intercept, and the x-intercept was 5, 0, then you would tell me the inverse has a y-intercept of 0, 5. Okay. Does that make sense? Those things make sense? Okay. So, yes, it does get more complicated, but you're still just thinking through, I'm trading the x, I'm trading the y. I just have to be careful as I'm trading it. I have to be careful that the way that I'm trading the x and the y makes sense. And I'm not just saying, I'm not memorizing, ooh, inverse means I flip. Inverse does not mean flip. Inverse means take x coordinates and y coordinates and switch them, okay? Because flip here would have gotten the wrong answer, all right? But trading x's and y's gets the right answer, okay? So think about switching x's and y's and not just flipping, okay? All right. So I passed out the assignments, yes? Let's go ahead and look at these and make sure they make sense. Okay. Number 1, give the coordinates of 2 points of the inverse graph. Give the coordinates of 2 points of the inverse graph. Yep, we're going to write it in inverse notation. So f inverse of 5 equals 2, okay? F inverse of 5 equals 4, okay? Explain why the inverse is not a function. Yeah. So the reason why is because you plugged in 5 and you got 2, and then you plugged in 5 and you got 4. The same input 5 had 2 different outputs. So if you were to graph this, you'd go over 5 up 2, over 5 up 4, and if you remember, functions have to pass the vertical line test. You can't have 2 points that are directly above each other because they don't pass the vertical line test, okay? So we're going to say the same, or 2 different inputs. Sorry, 2 different inputs. No. The same input. Sorry. The same input had 2 different outputs. It did not pass the vertical line test. Okay. How could we take a graph and then graph the inverse of a function? They gave us a graph. We got to graph the inverse. Remember in your head, switching the x and y, that's how we find an inverse. So what could we do? So there's 2 options. Some people would kind of... Yeah, that's what I would do. So some people draw this line in and then try to reflect the image. That's one option. It's a little bit harder to do that. What I like to do is find points that would be easy. So I'm going to find this one. I'm not going to use these points. Oh, it kind of looks like it's in a corner. I find points that are in the corners. Yep, good points that are in the corners. And once I have found enough points to be able to draw the whole image, then I'm going to call it good. So I might do a little bit more than that just so I can make sure that my V is going the correct way. and I'm going to write the points down, and then I'm just going to switch the X and Y for all of the points. So left 7, down 3. Left 5, up 1. Left 3, up 5. Left 1, up 1. Right 1, down 3. Now, it's a good idea to draw the line y equals x just to make sure that that line really is your line of symmetry, because I have students all the time who draw their inverse, and their inverse doesn't make sense at all, and they have no idea that their inverse doesn't make sense. So having that dotted line in there so that you know that's where it should be, like folded in half, that's a good thing to do. Yeah, we can do that one in a second. Is the inverse a function? Does the inverse pass the vertical line test? Wait. The inverse? No, the inverse definitely doesn't. Nope, definitely not. Okay. The other one is a cubic. Can you guys see how the other one's a cubic? So since there's not a lot of points where it crosses in the corner, I just did the corner and then I'm going to do where it goes halfway. Just so I have enough points to feel comfortable with what I'm graphing. So left, yeah. Left 3.5, down 7. Left 3, down 5. Left 1, down 3. Right 1, down 1. Right 1.5, up 1. And see, if you have the dotted line, you can kind of use the dotted line to help you with the symmetry. So I can see with this point that it kind of swoops towards the dotted line. So I can make sure that when I connect these, I swoop towards the dotted line right here. And then this part right here swoops away from the dotted line. So that's kind of helpful. And then it's not quite so hard to graph as I thought it was going to be. Yeah. Reminds me of a vase, kind of. If this was the bottom of the picture right here. Is the inverse a function? Wait. Yeah. Okay. Okay, I think the next several questions you guys will be good with. That was the notation we kind of practiced. So they give you some facts, and you just have to write the corresponding fact. Yeah, I think now that we've done that, you guys can do the rest. The ones that get kind of complex are 26, 27, 28, and 29. So let me know when you guys get there, and then I can help you guys out again. All right.